So welcome everyone, and welcome to this third and final webinar on environmental characterization. So today's webinar is going to be on environmental sampling, analysis, and interpretation. My name is Claudel Babineau-Boulé, and of course, if you have any question following this webinar, feel free to send me an email. You will have my contact on the last slide, or you can just directly call us at the FNQLSDI, and we're going to be pleased to answer your question. And of course, if we can't answer your question, we'll find someone that will be able to answer your question regarding the subject. Why should you follow this webinar? First, to understand what consultants do when they sample the soils and or groundwaters. It's also to deepen the understanding of the step of environmental site characterization, mostly today on phase 2 and phase 3 when you're gonna sample when you do an environmental site assessment. And also, of course, if you want only to refresh or maybe reinforce current knowledge you already have on the subject or just personal curiosity. So to whom is this addressed? Again, the series of webinars are only on basic notions, so we only go for the large overview of the subject. So if you work in the environmental field and if you're curious about it, this webinar could be very good for you. If you work in the field in environmental site assessments already and you know well the subject, so maybe it will be very basic for you. But still, if you want to follow it, feel free to do so. We first going to start with planning the sampling program. We then going to go on sampling techniques used on site, and then we're going to talk about analysis and interpretation. So those are the three chapters we're going to talk about today in this webinar. Just a small reminder of the main step of an environmental site assessment. If you watch or listen to the previous webinar on environmental site assessment, you should know all of these. You should know all this information. But globally, a phase 1 is the moment when you're gonna determine if there is an activity at the site or around the site that represents a risk of contamination to the site under study. And it will also give you the opportunity to define the areas potentially contaminated and the different source of contamination. But we will not take any sample during the phase 1. It's only about visiting the site, doing an interview, and doing a historical review. Then when you go to the phase 2, that follows phase 1, this is where you're gonna start to sample the site. So the purpose is to determine the presence and degree of contamination in the environment. So again, it follows the ASA phase 1. Phase 3 is actually similar to the phase 2, but we want to determine the presence and degree of contamination in the environment, but we want to better define the nature, the extent, and the specific location of the contamination to establish the potential cost of remediation. So the phase 3 is really to complete the information you had in the phase 2. And then again, finally, the last step of an environmental site assessment is the remediation or the risk management, which consists of reducing the risk related to the contamination or only to respect the applicable regulation and recommendation for the site under study. Today's webinar is actually related to the phase 2 and the phase 3 during an environmental site assessment because this is when you're going to take samples. So we're going to base the webinar of today on the different components of a phase 2 or a phase 3. So just a small reminder of the goal of the phase 2 and phase 3 is to determine the presence and degree of contamination in the environment. And the phase 3 is to complete the information which is missing in phase 2. The 4 components, the first one is planning the sampling work, second one field work, third one analyzing samples, and then data interpretation and reporting. So we're going to go deeper into each of these steps today to better understand the process of phase 2 and phase 3, and we're going to add to this all the environmental sampling techniques on the field that you can actually use. Chapter 1, planning the sampling program. Again, a very important step. Usually when we talk about soil contamination, we will sample soil, but we also need to sample water. And when we talk about soil, it could be soil directly at the site, or it could also be the sampling of a pile. Then when we talk about water, we can sample groundwater, or we can also sample surface water. For today, we're only going to talk about soil and water, but keep in mind that you can eventually have to sample sediments and residual waste as well. What are the different goals of soil sampling? Well, first is to demonstrate the presence of soil contamination. It's also to verify the conclusion of the previous phase 1. It's also to determine the level of contamination. You want to assess the spatial distribution of contaminants. You want to specify the stratigraphic profile of the soil. And you also want to specify all the different soil properties in order to understand the contaminant behavior in the ground. Before you go on site, you need to plan your sampling campaign. So there are different steps that you need to think about that we'll break down in the following slides. So first, you have to check the previous studies. You need to think of a sampling method. You will also need to choose the different parameters you want to analyze. Then the depth of the boreholes or the different trenches. Eventually, before you go on site, you also need to do a verification of the presence of underground infrastructures. And then you develop the sampling plan. Sometimes when you need to go on a site, you will know that there was a previous phase 1 and you will consult it before, but sometimes you don't necessarily know. So it's always important to make a little research about the fact if there is or not any previous studies. You can look for a phase 1 ASA, so it gives you more information on the site. It could also be a geotechnical studies. So any environmental study about the site could be very interesting for you because it can give you information about the site. So for instance, a phase 1, here we have a table of content of a phase 1, and you can see, for instance, that it's going to give you a bit of information on, for instance, fill materials, water bodies. You will also have photographs of the site. You will also know if there is a risk at the site, where it is located at the site. So the phase 1 will give you a lot of information regarding the site, the condition of the site, and what you will need to do in your sampling campaign. Then you have to choose what sampling pattern you're going to use. You have actually 4 different approaches. The first one is called the systematic random sampling, which is based on a regular structure. So imagine just a grid that you put on the site, and you would, for instance, take a sample every 25 square meters, for instance. Then you have the random sampling. It involves taking samples at random locations at the site. Then you have the targeted sampling that you will use a lot. It's actually at specific locations. So depending on the risk that you identified before, you might want to sample at that specific place where the underground tank used to be, for instance. Then you have the combined sampling, which is just a mix of the different approaches. Then you also need to know before you go on site what are the different analytical parameters that you're going to ask the lab to do. When you don't have any idea of the contaminant or the source of contaminant or the activities that has been occurring on the site, you can go with the basic analysis. So petroleum hydrocarbons, metals, and polycyclic aromatic hydrocarbons. But then if you have a better idea of what happened at the site, you can just go directly with the activity and see what are the different contaminants associated with that specific activity. So here you will find a few examples, but then if you need more examples, you can actually find a lot of information in the Guide de caractérisation des terrains from the Ministère de l'Environnement, and also in the sampling guide from the Ministère de l'Environnement, the Guide d'échantillonnage à des fins d'analyse environnementale, the first booklet on page 17. You'll find again this information on the last slide. But so if you want to have a few examples of activities that could actually leave some petroleum hydrocarbons at the site. You could find it in industrial activities, chemical industries, wood preservatives, textile, used oil. Then the PAHs, so polycyclic aromatic hydrocarbons, can be found in incomplete combustion, plastic, heavy petroleum products, such as diesel that you will find in the soil that will be there for a long time, can eventually become a PAH. Then you have also volatile organic compounds. They're actually a little lighter than other contaminants, so you will find them in gas, in dry cleaning products, solvent, paint, detergent. Another very common contaminant is metals. Actually, you have different kind of metals, but metals in general, you will find them in batteries and electronic waste, paint, different industries, industrial wastewaters, landfills, etc. And then another example is the polychlorinated biphenyls. You can find them in the former old hydrocarbon transformer, or just old transformer. They used to put this contaminant in the oil, and it could eventually leak and contaminate the soil. Another question you need to ask before you go on the site is how deep you're going to need to drill. So this will depend on the contaminant type, on the different characteristic of the soil, and also it's also depending on just logic. For instance, here's a question on the slide that you need to ask depending on what you can find on the site, but that's just an example. If there is, for instance, an underground tank buried at a depth of 2 meters, how deep should you drill? Well, if you want to know if the soil is contaminated, if there is any contaminant in it, and because you know that because of the gravity, the contaminant will probably go deeper, so you have to go deeper than the 2 meters, because if you drill only 1 meter, you won't see if there is a contaminant under the tank. So that is just simple logic that you need to think of before you go at the site. Before you go on site, you will also need to determine what is the best sampling technique for your site. So you will have a few questions to ask to yourself before you can actually choose the right sampling technique. So first, what is the depth that you want to achieve? Do you need to install an observation well? Because if you need one, the drilling machinery will be better because you can install it at the same time. Then what are the different geological materials that you can find at the site? What are the characteristics of the site? Is it close from is it in the community, close from the community? Is it a basement? Is it just an empty field? So this will tell you if you can access the site with a drill or maybe a backhoe. What is also your budget? Sometimes maybe one of the machinery can be cheaper for you because you already have one in the community, or you go for the cheapest one if you need. And then what are the different environmental impacts that the different machinery could have on your site? So you need to consider all these different questions, and then you can make the right decision about what is the sampling technique you should use. And again, before you go on site, there are a few things you need to think about, and one of these is all buried infrastructures. You need to ask yourself if there will be one. There is a free website that you can actually use, and they're going to locate for you all the underground infrastructure that are public. So it's called Info Excavation, and you see on the first image on the slide there is a square. So actually, when you go on this Info Excavation site, you make yourself an account, and then you will do a request about where you want to drill, and you will send that request, and they will send you back, if they have any information, they will send you back the blueprint of the place where you are, and it will tell you if there is underground infrastructure that are public. You know that the private one won't be on the map they will give you, but usually Videotron or Bell or maybe the gas can be on it, so it's always a good thing to ask them first. When I called them, they told me that they actually do all the entire Quebec, so even if it's in the community directly, you should be able to have some more information. Then if they don't have any, or if you want to have just more information, you can actually ask if they have any plan of the infrastructure at the Ben Council, or maybe the public work. And eventually, one of the best and more a very safe way to work is to use a private company that will actually locate with the good machinery the different infrastructures. And you see on the second image, there is a paint on the floor. It's orange. Maybe you've seen this before. This is usually when the info excavation go in the street, and they will locate with different colors. Where is the gas? Where is Videotron? Where is different underground infrastructures. When you have all this information gathered, you're going to be able to do a sampling plan and give it to the technician, or maybe use it yourself if you're going on the site. And on that plan, you need to write where you're going to do your boreholes or your different trenches. And you can write for every site what is the depth that you need. And, we put all the information, maybe also the different parameters that you want to analyze. And on this plan is actually a plan that was made after the results were received, but it gives you an idea of a plan with the different buildings and where you want to put your different boreholes. And you just want to put the maximum of information to make sure everything is clear for the person that's going to be at the site. Now we'll go more into details for the different sampling techniques that will be used on site. So the second chapter. Now we'll go through different aspects during the field work, such as soil sampling techniques, groundwater sampling techniques, survey logs, location map, and note-taking while you're at the site, then quality assurance and control program, and finally we'll go with health and safety programs. Let's start with the different technique you're going to use if you work in soils. Well, the soil sampling techniques could be working with boreholes or with test trenches. With boreholes, you can actually use a drill, as you see on the picture. You could also use a manual auger, or you can use a jackhammer with a split spoon. And if you work with trenches, well, you're going to go with a backhoe. What are the different characteristics, maybe pros and cons for each technique? Well, for the borehole, it gives you actually the possibility to go deeper if you use a drill. It is actually mandatory if you need an observation well, because you're going to drill and then you're going to install the well. And boreholes, if you work with manual auger or with a jackhammer, you can actually have access to buildings. Even if you use a small drill, it could actually give you access to a building, because if you work in a basement, you cannot bring a backhoe, that's for sure, but you can actually go with this very small drill or with the manual drilling processes. And then for the test trenches, well, it goes usually not deeper than 4.5 meters, depending if you use a backhoe or a hydraulic excavator. But the trenches gives you a very good overview of the soil composition, so it's a big advantage. But when you sample with the trenches, you usually sample from the bucket of the machinery, so you will lose a bit of the notion of depth. And then you can also lose a lot of volatile organic compounds. So depending on the contaminant, maybe the trenches won't be the best idea, but then sometimes it can be much cheaper, and it can give you a very good idea of what is in the soil. As we were saying, when you think of soil sampling, you have to think about different machinery, but you also need to think about different kind of samplers. So here on both pictures, you will see two different kind of sampler. The first one is made of plastic and it's called a liner, and the second one is a split spoon sampler. So both are used to grab the samples. Also, when you think of a surface contamination, you will have an interval to follow, and you have to sample every, for instance, 0 to 5 centimeters, then from 5 to 10 centimeters, then from 10 to 20, and eventually from 20 to 30 centimeters. This is when you have a surface contamination. But then when you get a depth contamination, you have something a little bit different. First, you cannot mix the different horizons that you will find in the soil. You need to take at least one sample from each stratigraphic unit encountered. Then you need to take one sample for each horizon in which the contamination is detectable. And finally, if you only have one unit, you need to take one sample every 0.5 meters, but you only need one analysis for your entire meter. So we just mentioned the kind of sampler you use when you work with boreholes, but when you work with trenches, well, you work a different way. First, we'll remember that it's the maximum depth of a trench will usually be around 4 meters, depending on what you need. Also, you will always sample directly on the wall of the excavation. The only thing is when the excavation is you cannot go down in the excavation unless the slopes permit it. So you have to check the regulation to see if you're allowed to go in the trench. If not, you're always gonna use the ditch bucket. So you're gonna sample directly the soil that is in the bucket. When you perform an excavation, usually you won't exceed the depth to be sampled for more than 30 centimeters. And you always take the soil only on one wall of the trench. And last thing to mention, when you gonna sample, well, remove the soil layer of maybe 2 centimeters that was in contact with the excavation equipment, just to make sure there is no contamination that is not at a good place. When you get to site, sometimes you're going to find some soil in pile, so you're going to need to sample in a different way. So how do you sample piles? Well, usually you want to have a representative sample of what is the pile about. So you're going to take 5 sub-samples from the entire pile. So usually each sub-sample is taken more than 30 centimeters below the surface of the pile. And then you're going to mix all these sub-samples to prepare only one composite sample. Also, if you have a small pile, you might take only one sample, but then depending on the quantity of soil you're going to have, so here you find a different quantity. So if you have less than 30 cubic meters, you're going to go for one sample. And if you have between 30 and 60 cubic meters, you're going for 2 samples. And each of these 2 samples is going to be composed of 5 different subsamples. So it's the same process for any kind of pile. It always depends on the quantity of soil that you're going to have. So how do you sample groundwater? Well, usually it's going to be with an observation well. So here on the picture, you have one picture of how it looks like from the outside. So this is an observation well which is being sampled. And on the other picture you have from the inside. So this is what you're going to put with the drill in the borehole. So you see it's usually you have a filter pack at the bottom of the screen so the water can get into the well, and you're going to go and sample the water that is there. There are many different ways to sample groundwaters, but here is just to give you an idea and have just a general idea of how do you usually sample groundwaters. So just a few aspects and a few generalities that you need to know is that usually when you plan sampling campaign, you need to plan several sampling campaigns each year in order to take all the seasonal low flow and recharge and any local variations into account. Then you need to apply always the same procedure to all monitoring periods. And also you need to avoid changing the sampling technique while monitoring is ongoing. So always the same way and many times during the year. And what are the main steps of groundwater sampling? So as I was saying, there are many different ways to sample groundwaters, but this is just to give you the general idea. So first, before you go to the site, of course, you're going to order the sampling bottles from the lab. When you get to the site, First, you're going to measure the water level, and you're going to use for that an electric sounder. So as you see on the picture, there is the yellow electric sounder over there. Then you need to purge the well to collect a sample that will be representative of the aquifer around the well. So you need to empty the entire well a few times, and then the water goes in again, and then you can sample that water, and it kind of gives you a better idea of what is around the and what is the aquifer. And then you're gonna sample, and of course always you're gonna ID your bottles, mention the weather, the day, the location, and eventually you're gonna send it to the lab. And depending on what you're sampling and the contaminant you want the lab to analyze, you might need to send the bottles very quickly to the lab, because sometimes there's a delay that you need to respect. And then when you send it to the lab, depending on what your needs are, you can mention the delay you need, so 24 hours, 48 hours, etc. And eventually you're just gonna receive the results. One of the most important things when you're on site is always to take a lot of notes. So you need to take field notes and photos of everything at the site. So first, when you do the borehole or the survey or the trench, you're always going to complete a soil description, a survey log, which is called. In this survey log, as you see on the image, you need to write down the depth of the trench or the borehole. You're going to write the colors, the others, the depth, the horizon, granulometry. So you write everything about the soil. And in this log, you also write the different sample that you have been taken. So when you send to the lab a sample, you know what part of the soil you're sending. Is it the bottom of the borehole? Is it only in the backfill at the surface? So it gives you information. You need to also measure all the different locations. So you're gonna do a detailed map of the site with the location of all the surveys. You write down weather condition, temperatures. Again, you take pictures. The purpose is just to have the maximum of information for the person who is not going to be on the site. Then when it will get the pictures, when it will get the survey logs, it will have a better understanding of what was on the site. Another important aspect that we'll talk about, but we'll not go into details, is a duplicate. Quality assurance and control involves usually duplicates on site. And what is it exactly? Well, there is a definition from the CCME. Field duplicates were split samples or co-located samples obtained in the field using the same sampling procedure are submitted to the laboratory blind, used to assess sampling and analysis precision. So globally, what it means when you do a duplicate on the site, you just want to make a copy of one of the sample you're doing. So you take the same soil, but you put it in a different bottle. It's just to make sure that the way you sample is the right way. And then when you send it to the lab, eventually you should have more or less the same result, because you've been sampling pretty much the same soil. And for this, you usually gonna maybe do about around 10% of the samples that you take at the site with duplicate, and then you send them to the lab, just to make sure you've been sampling the right way. Always make sure that you respect health and safety measures. For instance, you need to always wear your personal protection. When you're on site and you work with machinery, you need to wear your hard hat, safety goggles, respirators when needed, safety boots, etc. Also, when you work on site and with machinery, it's very important to always keep and maintain a visual contact with the driller or the operator of the heavy machinery, just to make sure he knows where you are. Another thing we need to mention, as I mentioned before, is you do not go down in the trench because it could be dangerous for your safety. You can only go in the trench if the walls respect the regulation. If not, well, you could go in the trench, and then if the walls collapse, then you could be buried, and it's very dangerous. And finally, another thing you need to remember is that there are not always, but usually they are bottles from the lab contain chemical preservatives. So when you put water in it, when you pull water, it could be dangerous if there's a splash or whatever. So just make sure you wear the safety goggles and the gloves when you work with chemical preservatives. Let's start now the third and final chapter on analysis and interpretation. So when you come back from the field, you will come back to your office with the different samples. You'll have a lot of samples. You won't send them all to the lab. You need to select the representative samples from your for your site, and also depending on what is the problem you're looking for and what you need for information. So in the sheet, the lab's going to give you before you when you're going to receive the different bottles, they're going to send you a sheet like this, and then you need to fill the form and send it back to the lab with all the different samples. You're going to write the name of your company, your name, who has been sampling, just general information, and then you go with the information about the different samples. So at the place where it's written in identification des échantillons, this is where you're going to write the different IDs. So if you send 5 samples, this is where you're going to write the samples, the name of the samples. So after that, you need to write also if you've been sampling soil, groundwater. You're just going to fill all the boxes and the different information you need, the date, where you've been sampling, the number of bottles you're having with you for the same sample, because sometimes for one sample you're gonna have one bottle for the metals, one for the pHs, so you might have one sample but 10 different bottles for the same sample. Then you need to send everything to the lab. You need to check the boxes for the right parameters. So if for the first sample you want to check only metals and let's say pH, well, you're gonna just check the right boxes, and then you're also going to include in this form the 10% of duplicates, and you're going to check the desired delivery delay, because sometimes you're in a rush, you need the result very quickly, so you can actually check if you want 6 hours, 24 hours, it depends on the lab, but you have different delays, and it's going to influence the price of each sample. And again, at the bottom of the page, you can also write if you what kind of criteria you need. Do you need the criteria from the CCME or the MELCC, the Ministère de l'Environnement? So we're going to talk more about the different criteria after, but this is just to give you an idea of what you need to send to the lab. So your sample and that sheet and you gonna write everything you need on that form, and you send it to the lab with the samples. After you receive the results, where you're gonna do all the data interpretation, and to do the interpretation, you're gonna need the guidelines. Depending on if you're located on federal land or on provincial land, you will use different guidelines. So you have the guidelines of the Canadian Council of the Minister of the Environment, CCME, and you have the generic criteria established by the MELCC. And they are both different because one is used on federal land and the other one on provincial land. But what you need to know is that the way they interpret the information is pretty much the same, because the maximum limit value will always be based on the use of the land. So you might be on provincial land or on the federal land, but you're always gonna look at what is the activity at the site. Is it agricultural, residential, commercial, industrial? And you're gonna do the interpretation regarding this activity. So the CCME guidelines, you have 4 different criteria or guidelines. You have the agricultural, residential and parkland, commercial and industrial. While on provincial land, you have criteria, so A, B, C, and D. So the A criteria is the background levels for inorganic parameters and limit of quantification for organic parameters. The B criteria is for residential use. C criteria is for commercial and industrial use, and the D criteria is actually based on another regulation, which is called Regulation Respecting the Burial of Contaminated Soils. So these guidelines are online, so you can actually go get them and have a bit more information to maybe have a better understanding of what it means. And if it's not very clear, send me an email, call me. I will be very pleased to explain it to you to make sure you understand the differences. It is always easier to understand interpretation with an example. So we're going to go with an example with the CCME and one from, for the Ministère de l'Environnement, so the different guidelines. So here, for instance, we have zinc. You will see there is always like a concentration that can be tolerated depending on the use of the site. So the first use, if it's agricultural, we can have a limit of concentration of 250 milligram per kilogram. It's the same for a residential use, but then if we have a commercial use, the level can be a bit higher, so the concentration could be to a maximum of 410 milligram per kilogram, and then it's the same for an industrial use. So this is how you would interpret the concentration with zinc if you were on the reserve. But then if you would be on provincial land, you would go with the general criteria of the Ministère de l'Environnement. And here, if you see the zinc at the bottom of the chart, for the A criteria, you can have a maximum of 140 milligram per kilogram. And here, if you see criteria B, which is residential, it's 500 milligram per kilogram. So you see with the CCME, the maximum was 250 for residential use, while with the Ministère de l'Environnement, you have a 500 milligram per kilogram for a residential use. And then the C criteria, you have 1,500 milligram per kilogram. So there is a huge difference here between the interpretation you're going to have to do depending if you're located on the reserve land or provincial land. When you receive the lab certificates, you're going to need to do the interpretation, but you will have a bit of information on the certificate to help you with this interpretation. So here again, the example, we can go maybe for the zinc, which is at the bottom, the last metal that is mentioned on the lab certificate. So you will see the milligram per kilogram maximum concentration for the A criteria. So the third column, you see it's 140, then you have the 500, 1,500, and you have the D criteria on the lab certificate. And the last column, you will have the results, and you have between like the parentheses the criteria. So because the zinc, we have a concentration of 1,910, we are located between the C and D criteria, so we have the criteria CD. If you look at the if you look at the cadmium, you're going to see that we have 1.6 milligram per kilogram. So this is between criteria A and B. So we have A, B criteria. So the lab will always give you that interpretation if you ask it to do it. So when you talk with the project officer at the lab, please tell them that you're going to work maybe with the criteria of the Ministère de l'Environnement, or you're going to work on reserve, so it's going to be the federal criteria. And they will give you an Excel version of all the results, so again, it's going to be easier to interpret the results. And as I was saying, mention it to the project manager at the lab, because they know how it works, so they should be able to help you out. And also, if you have any question on how to interpret the lab certificates, if you're not sure about the results, well, call the lab, ask them. Usually they will always be there to answer your question. And as we were saying that we interpret the results depending on the use of the land, we're going to do the same with water, but it's going to be depending on the use of the water. So the maximum quantity of contaminants guideline in water depends on the main use of the water. Is it for protection of aquatic life, fresh water, marine, livestock, drinking water? So again, you'll have different criteria, and you can all find all these criteria online. And here is an example of a grid you can find online, and this grid will help you out understand if the water is considered contaminated or not, depending if it respects the concentration allowed for fresh water, for instance, or for irrigation water. Before we complete the webinar, it's important to know that all the information we've been mentioning and all we've been talking about is actually available online. So you have different available tools and guides online. All the information from the federal government, the CCME, are available online. All the information also from the provincial government of Quebec is also available online. So here you have the different guidelines, CSA standard that we've been using or talking about that you can find online. So you have the different link. So feel free to go and search for more information, or if you want to review something, you'll have all the information online. And these sites are mostly about soil, and the following page, the following slide, will be mostly on water. So as I was saying here, you have the water quality guideline of the CCME, you have the groundwater criteria of the MLCC, surface water criteria, because you have different kind of water, surface water, groundwater. So everything you need is usually online, but if you need anything else, please feel free to contact us, and we will be very pleased to send you more information and other website that could be useful for your studies. So this is the end. If you have any question, as I was saying, feel free to send us everything by email. Or if you need more information, you have a specific request, well, you have my information here on the slide, and you can just directly call us at the FNQLSDI. I also would like to thank the Indigenous Services Canada for their financial contribution. And again, this webinar was the third one of a series of 3 webinars. If you haven't watched the other webinars, you can go online. They are actually on our website. They're going to be in French and in English. So thank you very much, and I hope you enjoyed it.